This is my anomaly detection project, and this detects anomalies before they happen in the market. So depending on the previous anomalies that have happened, I have trained a machine learning model that is able to determine whether anomaly is happening or not. Okay, so the data that I have used is this one. So as you can see, we have a label data with 0 and 1s, like 0 means no anomaly, 1 means there's an anomaly, and then the date, and then also the tickers, right? So for all the tickers based on that date, we have the stock price, right? So based on this, we have whether it's an anomaly or not. So using this label data, I have trained a machine learning model that determines for us whether it is an anomaly or not. Okay, so first thing I did is cleaning up the data. This is what you see, like understanding the data. So everything that you see here, for example, here we have how many anomalies do we have, how many no anomalies do we have. This is a distribution, and this is also the distribution of like what's the anomaly that's happening. Like if some stock market values are like being very affected by anomalies, we might want to consider them as well differently. So that's why I have this graph showing all the anomalies, how they happened, right? And this is like per year one for drawing purpose, but we can also make it like 100 here, and then have the anomalies being drawn like twice per year or so, right? So we would have like a more condensed graph here. Okay, so and then we have also feature engineering that I have implemented, which is like adding lags and also computing RSI to be able to determine, to be able to improve the accuracy and performance of our models. And then I have trained two models, which is random forest and the XGBoost model. So as you can see, both have like their own performance. They both perform good on no anomalies, but for anomalies they have they don't detect them pretty well. So I need to do more work on this one, right? So 72 and 93. To be honest, XGBoost does very well on detecting recall for anomalies, which is good, but we need to improve the precision again to make it balanced, right? So for that reason, I have performance after PCA right here. I have performed PCA for both XGBoost and random forest model, and then it didn't perform well on recall again. So this is what we have. It didn't perform well on recall again after correlation analysis for random forest, and after PCA, XGBoost performed good on precision and also recall improved, and that's good. And then again on after correlation analysis, it did average on both of them. So I think the PCA was better than the correlation analysis, which is okay. So I have also tried to do right here a hyperparameterization using grid search, and then trying to see how it would affect, but it had no fruit. So after that, I have tried to select the performant model, and then which in this case I think balancing the precision and the recall is the PCA with XGBoost. So I have saved that model here, right here, and I have them right here, as you can see. And then I have loaded it, and I can do any kinds of predictions whether an anomaly is going to happen or not, like this pretty easily. Yes, thank you very much for everyone. If you have anything to like to add, please let me know, and I would be happy to discuss that.